So the last part of chapter 54 is going to have to do with trophic structure, which is going to be like food chains and food webs and that type of thing. So if you look at this picture, let's see if I can get it to come up. There we go. This is going to be a typical food chain, right? So you've got your plants at the bottom or your phytoplankton at the bottom, and then you've got your top carnivores at the top, right? So this is going to be a food chain. Now, food chains are good. That's a good starting point. But the problem with the food chain is when you try to put things into categories, they may not always fit into that one category, right? So, maybe this guy's an herbivore in this case, but maybe it likes to eat other insects, right? So a food chain is a good starting point, especially because you want to label the different levels, which we will get into. But really, what's more accurate is going to be a food web. So here are some food webs right here. And so what happens is this gets a little bit more complicated, but it makes a lot more sense because it kind of shows how things fit together, right? So, let's see, here's another one that's kind of a food chain, but it's not exactly accurate because maybe that bird doesn't always eat that fish, right? And then once again, here's a food web, and you can definitely see that you've got more of an intricate setup. So Charles Elton was going to be the one who talked about food chains, and what he found was that food chains are usually about 4 to 5 links long. And the reason for that is because you run out of energy the higher up you go. And the next chapter will get into how that actually works. The other thing he came up with was the whole food web idea. He said food chains are great, but really we should divide these into food webs because things fit in at different places. Makes sense. Okay, so I talked about what limited the length of a food chain. It's that you run out of energy. And so we will talk about that in a later chapter. But what I want to get to next is going to be what are called dominant species and keystone species. So these are going to be extremely important to identify when you're looking at community structure because they can have a very, very large effect on the community. So we're going to start out with dominant species. So in this picture here, you can definitely see that these pine trees are the dominant species in this area. The way you can figure it out is 2 ways. First of all, they may have the most abundance, which means just total numbers. The other way is that they could contribute the most to the biomass, right? So like if you were to take them all and weigh them, they would weigh the most out of anything in there. The reason that we talk about dominant species is because if they had some disease and they all got wiped out, the whole community is going to change drastically because they played such a huge role in it, right? So you can imagine if we cut down all these trees or if a disease did come through, all of this understory would have less competition and would probably kind of take over for a little bit. So that's why we worry about a dominant species. Now, here is an example of a story about a keystone species. So what you're seeing in this picture is actual kelp forests. So kelp is that kind of tall algae that's growing in the background. And what's in the foreground here are going to be urchins. Urchins love to eat kelp. So the urchins keep the kelp forests at a normal level. Now here we have the adorable sea otter. And in this picture you can actually see that the sea otter likes to eat urchins. So we've got a nice little balance. The urchins keep the kelp in balance, and you've got the otter keeping the urchins in balance. Perfect. Until these nasty humans come along and say, otters are cute, but I would really like to wear their fur. So humans started killing off the otters, and what happened is you all of a sudden don't have a predator. So what do you think happened to those urchins? Exactly. The urchin population just exploded. So what do you think happened to the kelp? The kelp population pretty much got wiped out. Well, that kelp forest is important because there are tons of fish that start their lives there. There are a lot of predators that like to hide in there and then dart out. So the whole food chain collapsed just because of that otter being killed off, right? There's obviously stuff being done about that now to bring them back, but it really, really dismantled the food web. So that's an example of a keystone species. Maybe there weren't a ton of otters, but what they were doing, their job was to keep everything in control. And the second they were gone, everything got out of whack. Another one closer to home is going to be our lovely little prairie dog, right? So the prairie dog is going to be a keystone species because it actually provides a lot of habitat for other organisms. So one thing that it does is it likes to mow the lawn around it so it can see, and the grasses that it's doing that to actually prefer that, and they grow stronger roots as a result of that. So they're very healthy for the grasses and plants that are in a prairie dog town. Another reason they're important is because they're an important source of prey. I know that is a really graphic picture, but anyway, they are an important source of prey for birds of prey like that, or coyotes and that type of thing. And then another reason why they're so important, these guys are so cute. This is a burrowing owl. This is actually a baby burrowing owl. Burrowing owls just get to be like that big. I mean, they're so cute. And burrowing owls obviously like to live in burrows under the ground, but they really don't like to dig their own burrows. So they kind of depend on the prairie dogs to abandon some of their tunnels, and then the burrowing owls use those. So you can see all those different organisms are connected to that prairie dog. And so when you lose that, everything can get out of whack. Okay, so that's going to be dominant species and keystone species. The last thing we're going to talk about is going to be disturbance and community structure. So disturbance in a community is going to be anything that kind of shakes up that community. It could be temporarily, and most of the time it is, and a lot of times disturbances are necessary for that community. So examples would be like big weather events, mudslides, fire, that type of thing. Unfortunately, human activities can be an example too, right? Pollution, overhunting, cutting down forests, that's quite a disturbance as well. So if we talk about marine communities, they're going to have disturbances from things like tropical storms and hurricanes and stuff like that. Very interesting, when I was doing my stuff, I actually saw that if there was a hurricane on the horizon that was near where I was doing my counts, I couldn't even do my counts on the fish there because the fish would just take off. Like they knew that that thing was coming. So kind of interesting how the community can react to that. So if we look at this picture here, there's a great example of a disturbance, right? You've got a fire. Now, a lot of times fires are a good thing because there are some seeds that won't open unless they get exposed to fire and that type of thing. And if you look, just a year after the fire, everything's coming back, right? So fire is one of those necessary disturbances most of the time, right? We're doing a good job of screwing that up, but we'll have a whole day we'll spend on that in class. Now, that's a natural disturbance, right? You had maybe a lightning strike or something, the fire went through, and now everything's coming back. That is different from a human-caused disturbance. If you think about human-caused disturbances, that could be stuff like pollution or just breaking down a habitat. So here's an example of a human disturbance. So you got a nice reef here, you got a bunch of groupers and snappers hanging out on this reef, and there is something that we do to get shrimp called trawling. And trawling is basically where you drop a net behind a boat that has weights on it, and those weights take the net down to the bottom because that's where the shrimp are, and then they just go forward with the boat, and the boat just drags that net along the bottom to get the shrimp. So here's what that area looks like after a trawl has gone through. Not good, right? This is going to take a long time to come back. Coral grows about 1 inch a year. So you can imagine that this is going to be a long felt disturbance compared to that fire situation where even a year after it looks so much better, right? So human caused disturbances can really cause a lot of damage that sometimes isn't even repairable, right? Look at the Rocky Mountain Arsenal. There's some serious stuff going on over there. All right, so let's say a disturbance does come through. What's going to happen is called ecological succession right after that. And that's going to be the transition in species composition over time. So going back to this picture, you can see that you've got small shrubs and little flowers that are going to colonize the area first. And then if you come back in a couple of years, there's probably going to be some little sapling trees starting and that type of thing. So that's ecological succession. So there's two types of succession. You can have primary and secondary. Primary succession is going to be in an area where there isn't even soil yet. So if you think about an area where a glacier has retreated and it's just rock, or a new volcanic island that has just rock, those are going to be examples of where primary succession is going to happen. And what's going to happen is moss and lichens. Lichens are going to be those like orange and gold and green things that you see growing on the side of rocks when you go like hiking and stuff. those are going to come along and get onto the rocks and start breaking the rocks down into soil. Not a fast process, but that's how they work. So that's all going to be primary succession. Secondary succession is going to be where you had a community, it got wiped out by some event, however, there is still soil there. If you think about an abandoned farm, right, there's no plants there, but there's still dirt. A burnt field or a burnt forest, that would be secondary succession as well. So disturbances aren't always the worst thing. Human caused definitely seem to be more serious. And then you're going to have that succession happen after that disturbance.